So for this one, the eagle is flying horizontally at 6 meters per second with a fish in its claws. It accidentally drops the fish. Okay, so the fish is going to be dropping. So this is to drop the speed. So that will be the speed of the fish, which is v. Okay, so we want to calculate the components. Remember, when you're dealing with 2D, you must calculate the components. You split your vector, which is the speed of the fish, into components. Okay, so we are going to split it into x and y components. How are you going to do it? You are going to say Vxi, it will be always 6 cos. So Vx is always the cos of the angle. But because it's horizontal, which implies that the angle is 0. So for every horizontal, it implies that the angle is 0. Horizontal and vertical, it implies that the angle is 0 there. So it will be 6 cos of 0. So the component of the x, it will be 6 meters per second, because cos 0 is 1. And we go to also this one, v component, vy, in the y direction, it will be always sine. So sine corresponds to y. So 6 sine 0, it's always 0. That's why in the y direction, it's a drop. When you drop, so which means the v initially in the y is 0 meters per second. That's the interpretation of drop. Horizontal, it implies that the angle theta is 0. Okay. So for question 5a, we want to know what is the time when the speed of the fish. Remember, v is the speed of the fish. So when the speed of the fish that has been dropped, when it is doubled, which means when initially v is equals to vxi. So here initially, that is our speed of the fish is 6 meters per second, which is the same as the component of the x. Okay, so as the fish is dropping, at a certain time, the speed would have doubled. We want to calculate the time, that is for A. And it continues to drop again. We want to know by how much will this speed has doubled again. So 2 times 2, it has doubled, which means it's 4. Okay, so later we'll calculate what was the change in time, the increase from here to there. So we need to calculate the time here, we calculate the time there, then we find the difference. That's how we can find the change in time. So the time when the speed doubled from v to 2v. And then also want to calculate the time when the speed 2v doubled from 2v to 4v. Okay. So here our v is equal to square root of the components, x component, y component squared. So our x component is that one. And then our y component is 0, the sign. So we find out if you square both sides, squared, then we'll be left with the inside. Okay? Which implies that v is equals to vxi. Okay? So at any given point, the speed of the fish is the same as the component of the x component. So we want to calculate the time. But however, the vyf at any given point, it's no longer 0. It will change. This is going to change with the time. It's not going to remain as 0, but this will remain constant throughout. Vx will be a constant. And remember, acceleration for this one in the x is always 0. Okay? Acceleration in the x for this projectile, for this drop, is always 0. So we are going to start acceleration in the y. Acceleration is always velocity over time taken. Changing velocity over changing time. So ay is equals to vy over ty. We make vy subject of the formula, which will be the same as ay times t. Okay. So we know our speed of the fish, v, is the sum of the components. Okay, so initially the sum of the component, initially it was 0 because sine 0 is 0. That's why it ended as v is equals to xi, which means that any time the speed of the fish is equal to the component of the x component. However, the y is going to change. Initially y component was 0, but the y component as time moves by is no longer 0. It changes with time, the y component. So we want to find the time when the speed is double and the time when the speed is 2 times double the one before, which is 4v. So we substitute. Our v is equals to the component of the x, where there is v y squared. We substitute by a by t, which means acceleration times time equals to velocity. You substitute now. It's no longer 0. It's only 0 here, but here at v, at y, at vf final, it's no longer 0. It's a certain value. So we want to double the speed. Okay, the speed for it to double, which means it's going to be 2v. This is the speed of the fish. Now 2v is equal to square root of x component squared. This is the y component squared now, but written in a different way, which is acceleration in the y, which is 9,8, multiplied by the time taken. That is what we are looking for. So we substitute. This is the same as that. So where there is v, you just replace with vxi. Okay. What do we do now? We square both sides. 2 squared, it's 4. Vxi squared, it's a square. Then we have removed the square root sign. We are left with that. Okay. We push this to the left, it's a negative. This remains as it is, but you square the 9.8, you square the t. Subtracting gives you 3. Vx squared I is equals to this squared multiplied by the t squared. Okay. So from here, we just divide both sides by 9.8 squared. So t, we remove the square by making square root of this divided by 9.8 squared. Then t is equals to the root of that. Then we know that vxi initially its component was that. So the final t is 1.06 seconds. Rounded off, it gives you 1.1 seconds. So that was the time for the speed to double.